Okay, we are live.
Nice.
Okay.
So first one is true, right?
Yeah. Okay.
Which of the
Okay.
number two?
Yeah, I was just going to ask you to read.
Okay. Which of the following variables is or are categorical? The number of animals in zoo? Probably not. A randomly selected brand of toothpaste at the convenience store?
Mm-hmm. Yep.
I would say so. Yeah. Okay. So number three, the mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their scores was 112. Which of the following statements is true? For some reason, I feel like, isn't the first one true? Like 100 is a parameter, like of test scores in the United States.
This is also mark all that apply because I'm trying to select more of them, and yeah, you can select.
Yeah.
Okay, so maybe
I think there are two that are true.
Okay, yeah. So 112 is a statistic.
So yeah, 100 is a parameter. I think that's the first one is true, and 112 is a statistic. So first one and fourth
Yeah.
one, I think.
Okay.
Yeah, I agree.
Cool. Rotham City has four distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values, and another has an extremely high property value. Property taxes are usually roughly proportioned to property values. What type of sample should we collect to gauge the residents' response to a proposed increase in property taxes? I'm going to go with cluster, I think.
I think a stratified sample could probably do better.
Okay.
Just because in a cluster you would choose one neighborhood and then survey everyone in that neighborhood. But
Okay.
since there are like different kind of people in each neighborhood, I would probably go for the stratified so that I could pick, I don't know, let's say 10 random people from every single neighborhood and then just use those as a sample. But I don't know. Gabriel, what do you say?
Daniel, can you hear me?
Yeah.
Okay.
So Gabriel, what do you say?
So
I think he froze again. Oh my days.
Okay,
wait a second, let's wait for this. Gabriel. Oi. It's weird because I think he can't see us, but we can see him. Well, he just went off.
Yeah.
Let's see if he's coming back on.
So for number 5, it says it talks about like when design experiments are conducted in a public school system, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students. So there's like a lot of school districts, and they choose one, and then they choose all the 4th grade students, or yeah, all the 4th grade students in that district.
No, they first choose a district, then
Right.
they choose randomly
Teachers?
some teachers, and then
Okay.
they take all the students of those
Okay.
teachers.
Okay. Okay.
So I think this one could be the cluster sample.
Okay.
Because you have a first selection that can
Okay.
also be random.
Okay.
But then after you have selected something, then you take data from everyone. You're not then going through a random sample, but you're just surveying everyone.
Okay. 6. Do you know what happened to Danielle?
I have no idea what happened to my brother. I'm going to try calling him.
Okay.
Oi. Sì. Sì, sì. So you cannot get in? Non riesci a entrare? Mm-hmm. So is it working or not? Wait a second, I'm going to try to send you an invite. Okay, I sent you an invite. Okay, I'm going to put you on speakerphone on my phone, and whatever, as like you're still participating because Isa is going to hear you. I'm going to hear you, so
Yeah,
you're going to participate. So whatever. I'm going to call you. I'm going to call you on WhatsApp. Okay. Let's try to be creative.
Yeah, that's fine.
Okay. Try talking, Gabriel.
Can you hear me?
Isai, can you hear him?
Yeah, I can hear. It's good.
Okay, he can hear you. So I will be, the man in the middle.
Yeah. All right.
Yeah.
So I think we were on number 6.
Okay, we got to number 6, Gabriel.
To number 6, I got to number 3.
To number?
I actually stopped at number 3. So,
Okay, so number 4.
Can I catch up with number 4? It's a CD. So either a stratified sample or a cluster sample.
Okay, I was for the stratified and Isai was for the cluster.
Non ho sentito niente. Can you say that again?
I was for stratified and Isai was for cluster. So what would you say?
I think they're both two good examples. If I should pick one, I will probably pick stratified.
Okay. Let's go for stratified and let's see what happens. We have 2 attempts, so whatever. Let's go.
Sounds good.
The 5th one. We went for a cluster.
Yeah.
Yeah. I think cluster sample.
Okay. So number 6.
I can read this one.
Yeah.
Okay, just cool fun.
Yeah. Try talking, Isai, and Gabel, let me know if you can hear him.
Okay. At a school fundraiser, the names of every person who attended was entered.
Okay. He cannot hear you.
Oh, okay.
But,
That's-
whatever.
Okay.
Just read it,
Okay. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? I think it's the first one, right? Simple random sample.
Yeah. Simple random sample, Gabriel.
Yes.
Okay, yeah.
Okay, 7. A special interest group is conducting a survey regarding wolves in Yellowstone National Park. To gauge opinion on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100 people. Which of the sampling schemes was implemented?
Okay. So number 7 we're reading, okay, Gabriel? So which one do you think it could be, Gabriel?
Well, I had some thoughts on this one because they're like getting people from a list of registered Republicans. So I'm not sure if there will be a simple random sample, even if they get like random people from that list.
Yeah, for sure. Surely I wouldn't say it's a simple random because, they are already dividing it in 2 categories. So if it's random, it has to be systematic. But I don't know if it goes into systematic or,
I would go with stratified on this one for me.
Yeah, there's not. Yeah, it's the only real option from the thing. So yeah.
Systematic random sample, probably.
Okay, we all agree on that one then.
Well, but is it a No, it's not a systematic.
No.
Wait a second.
Well, because
it's a stratified random sample.
I think so.
Yeah, because systematic would be, every.
Right.
Yeah, every 5th
Whatever.
or every whatever. Yeah.
Exactly. So stratified random sample. Okay.
Lesson, or excuse me.
Stratified random sample isn't like that you get actually from each category.
Yeah, from each category, you're going to get some random samples, and that's what they did. They took Democrats and they took Republicans, and they took random samples from both of those.
Okay.
Okay. Cool. So we have to do the crossroads purchases. So let me check.
Okay. Using software, calculate the mean of the amount spent. My computer's still being slow, and I'm trying to open the Excel file right now.
Yeah, I am opening it at the moment. Okay, and I'm going to open the other one as well. The quantitative descriptive data. Okay.
No, it doesn't work.
Okay, so what is it asking here? Using software, calculate the mean of the amount spent, round to 3 decimals. So the mean of the amount spent. I have 4.771.
Yeah, me too. I got that same number.
Okay.
4.77.
So Isa, you agree with 4.771. Gabriel?
Yeah.
4.771.
Okay, yeah. Sweet. So let's go to number 9. I'm going to read that. Using software, calculate the standard deviation of the amount spent, round to 3 decimals. So standard deviation, 1.912.
Yeah, 1.912.
Gabriel?
Just 1 point.
Yeah. 912.
912.
Yeah.
Okay.
Okay. So start by creating a histogram of the amount spent in Crossroads purchases. Then mark the following statement as true or false. I created a histogram representing the amount spent. Okay.
Okay.
All right. Something wrong. So.
Okay, so are we all on number 11 right now?
Yeah, just a second.
Okay, no problem.
Because I'm trying to just do a histogram from scratch, just very briefly. Okay. Okay, so I marked it true. All right, so if you want to read, Isai.
Okay. So it says, Jessica Meir and her research team measured the body temperature of a sample of diving elephant seals. A thermometer was placed at a specific location on each seal to measure its body temperature. The body temperature of seal tends to decrease as they dive. The researchers estimated the typical body temperature of each seal at the time they initiate a dive and called this the representative temperature of the seal. Thermistors were placed in the hepatic sinus of 4 of the seals, named Bodie, Robert, Larry, and Peter. The seal's body temperature at the start of the dive was calculated to be that. It says complete the following table and use your work to answer the next 4 questions.
Okay.
What is the value of the number that goes in the position marked with an A?
Okay. So we have to find the mean temperature first. So we have those 4, and we have to come up with the mean. So let's see. So is it 30? Oh, I cannot use my calculator.
Is it 38.075?
I can't use my calculator because I'm on the phone with my brother. So. All right. So what do you come up with, Gabriel?
The mean.
Yeah, the mean of those 4.
38.08.
Sorry? 38.08. What was your what's the mean you came up with, Izzy?
38.075. But yeah, I think if you round
0.75. Okay. Yeah, so it's
and
the
then
same.
And then since you subtract x from the x bar is the average, right?
Sorry? What did you say, Izzy?
Oh, x bar is the average, right?
X bar is the mean of the observation, and
the mean
X is the actual observation we have there. So we have to do 37.91 minus the average that we. Oh, Gabriel.
Yeah, I'm back.
All right, I'm going to turn this off then.
Oh, okay.
All right. So we're back in business. All right. So what was the average again? So 37.91. What was it again?
I got 38.075.
0.75. Okay. So we do. Plus 37.91. So it's, round your answer to 3 decimal places, it's minus 0.165.
Yeah, I got minus 1.675 too.
Sorry.
Number 11.
Number 11, minus 0.165.
Oh, okay. I had like 1.7. So.
Yeah.
One 6.5.
Yeah, because we have to round to 3 decimals.
Yeah, I rounded before just because I saw that
Yeah.
all the temperatures were 2 decimals.
Sure. Okay.
The number 12.
Yeah.
I had 0.689.
Sorry, say it again.
0.68.
Minus?
No, just not minus. 0.689. That's what I got.
I got 0.680.
680. Okay. Well, could be just I rounded before. Yeah, that's probably why.
Okay, wait a second, because I'm just making up a mess.
What is the mean that you got, Isai?
I got the mean. I got 38. Hold on, just a moment. 38.075. That's the deviation from the mean. And then when I squared it, oh, excuse me, it's negative 0.825. Yeah. Did you get negative 0.825?
I didn't.
You didn't.
Okay.
Just a second, because
I'm confused. I need
I'm
to
so
do
confused.
it again.
I'm doing it all over again, you know.
Me
Okay.
too.
Okay.
So the mean I got is 38.075.
Exactly.
Okay.
Yeah, that's right. That's what I got too.
So we then do 37.25 minus 38.075, and we come up with minus 0.825.
And then you square it, right?
Mm-hmm. And it's 0.681.
Yeah,
Okay.
that's correct. I think. I mean, that's what I got.
Yeah. So what quantity? Yeah, go.
Yeah.
Just go ahead.
Oh no, you can go. You can go for it. My bad.
What quantity is equal to the sum of the numbers in the squared deviations column? So it's the variance, if I remember correctly.
The quantity is equal to the sum of the numbers squared. Well, not the mean, not the
Yeah.
standard deviation, so the variance. I'd say.
How do we get 14? Are we on 14 yet or no?
Yeah.
Okay.
Okay.
How do we get the standard deviation of temperatures?
Well, if we had to do it by hand, we would have to find all the squared deviations, and
then divided by the number minus 1 or
no,
something?
and then make like a square root, and then
Mhm.
divided by the number of observations minus 1. That was the
Yeah.
formula. So if we want to do it by hand, fine. If not, we can just use our dear friend Excel.
Love it.
So 37.91. 37.25. 38.98. Nah. Oh, stupid thing.
Non si dice.
I forgot that I have to put commas in my Excel instead of dots for decimal places.
Standard deviation. I don't remember
I
which.
came up with 0.715.
That's what I got too.
0.715. Yes.
Okay.
So 0.
Their deviation
So
cannot be
15.
negative, right? Because it's squared, or because
Yeah.
is that right?
What? Oh, are we 15?
So number 15 is false.
Yes. Okay, information. In the same study, the researchers placed thermostors, whatever, temperature sensors, in 3 seals named Cheeks, Tarbus, Pars, and Patty. That's an interesting name. Near their spinal cord and the brain in the extradural vein. Gosh. They place, that's still a hard word. They placed their mistors in 6 other seals named Sir Richard, Jerry, Sammy, Knut, John, whatever, in their aorta, the largest artery in the body. Finally, they placed their mistors in 4 other seals in their hepatic sinus. The results from this study are summarized in the table below. Blah, blah, blah. Which location resulted the most consistent temperature measurement from one seal to another? Well, the smallest standard deviation is extradural.
Mm-hmm. Yeah.
The number of hours students spent studying for an exam were recorded. The data are represented by the box plot below. What is the third quartile? 8? Yeah.
Yep.
Okay. What percentage of data lies between 4 and 8 hours? 50%?
Yeah.
Yes. If the answer is yes, then okay. So that's 50.
Okay.
It has to be entered in as 55, right? Or 50, I mean, excuse me.
Yeah, just
Not
50.
50.
Yeah, just 50.
Yep.
Okay.
So moving on, an observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 parts per million are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52, and values outside of this range are unusual. We will assume that, okay, whatever. It's reasonable to assume the measured nitrate concentration is normally distributed. So estimate the mean of the measured nitrate concentration in Rexburg's drinking water.
The mean is
Yeah, so we should just take those 2 values that are opposite one to the other.
so 1.59
We add them up and we divide by 2.
plus 2.52 divided by 2. It should be 2.055.
Yeah. Do you agree, Zay?
Yeah, I agree.
Cool. Estimate the standard deviation of the measured nitrate concentration in Rexburg's drinking water. Okay. So we can do 2.52 minus 2.055 and divided by 2.
Yeah, for sure. I think the keys are right on the board. Usually. Yep.
So do you agree with my thinking?
0.465.
So how did you get that last one, number 20?
So number 20, I was saying if you do 2.52, that it's
Okay.
like the highest limit that they said, and you subtract from that the mean that we found, 2.055, and then that you divide it by 2 because that's 2 standard deviations away. So if you divide by 2, you find 1 standard deviation.
Okay.
So I come up with 0.233.
Yeah, I didn't divide it by 2. So that's
2.32.
33.
Oh yeah, 0.23 because you round it.
Because you could also do 2.52 minus 1.59 and divide that by 4.
Okay.
Because you have 2 standard deviations in one direction and 2 in the other. So if you
Okay.
find what's in between, then you divide it by 4. Okay, question
Okay.
21. Between what 2 measured nitrate concentrations do approximately 68% of the data values lie?
Well, I did 0.233 plus 1.59, and it's 1.8225, so 8223.
And the other one is 2.288. I just did it.
Okay.
Okay, so the last one.
So it's the It's the last one.
Okay.
The admissions committee for most Masters of Business Administration programs require the Graduate Management Admission Test as part of the application for new students. It has been shown that the score on the GMAT are normally distributed with a mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admission to the MACC program in the School of Accountancy at BYU is 500, but it is rare for students with scores less than 600 to be admitted. Okay. What is the probability that a randomly selected student will score above 542.3? Rare. The probability that a student will score higher than that is 50%.
Yeah, I would say so.
%50.
Yeah, because the mean is right in the middle of the curve, so it divides it.
So
in half. Yeah, exactly.
So how do we write that? Like 0.5,
Mm.
50, and I think it's 0.5.
Yeah, I would say 0.5.
So what is the probability that a randomly selected student will score below 600 on the GMAT? Oh, this is a little interesting. So I think we have to calculate it. 600 minus 542.3 and divided by the standard deviation, 120.54. is 0.479.
Let's go and put that in the probability applet. Okay, so what was the question again?
What is probability that a randomly selected student will score below 600?
Below. Okay, so we take the middle and the far left of our z-score.
Yes.
So it's 0.684.
Okay. Perfect. What is the probability that a randomly selected student will score 600 or above? Well,
So to the right.
Yeah.
So
0.316.
316.
Mm-hmm.
316. Okay.
It didn't say how many digits we had to put after the comma. How many places?
Nope.
Well, I'm keeping 3. Whatever. Okay.
Find the GMAT score that corresponds to the 10th percentile. So we put 0.1 in the, what's that called? How's that called?
It's the area.
There we go.
Okay. Come up with 387.768.
For 25
Yeah.
point, what did you say?
387.768.
7, 6.
Did you get the same? You say?
How did you get that one? Did you put
So in the normal probability applet, I put on
okay.
the area 0.1. I highlighted the far left.
Okay.
Then I use the z-score that it's minus 1.282.
I got minus 1.645.
Yeah, me too. It's minus 1645.
Oh, minus 1.282, right? Is that what you said?
Minus 1.282.
Yeah, I don't know what happened, but I think when you,
Oh,
I just
yeah.
fixed it right now. I don't know why
yeah.
why it
I
does
had
that way.
the far left and the far right area selected.
Okay.
Yeah, that's why I got that. So minus 1, 2. No,
Minus 1.282.
Okay, yes, yes.
Okay.
Then
I
you
got that one. Then I multiplied that one for the standard deviation.
Yep.
And then I added the mean.
Okay, perfect.
So do you get now 387.768?
It is correct.
Okay.
Find the GMAT score that corresponds to the 90th percentile.
6.832.
Huh.
So it's the same standard, the same z-score.
Yeah.
Yeah, because 10th and 90th have the same extremes. So 1.282 multiplied.
What's the standard deviation? I got 696.832.
For number 26.
Yes. Daniel?
Daniel froze.
Oh, yep. It's his turn.
Yeah.
Oh, it says round to the nearest whole number. Now I know how you guys feel. I'm gonna call him this time.
Yeah. So can I just check my answers with you for the last few ones before he gets back on?
Yep.
So for 23, you got 0.684.
Okay, wait. 23.684. Yes.
24, 0.316.
0.316. Yes.
25, 38, 7.68.
Yes, but I read that we should round to the nearest whole number, so I got
Oh, so
388.
okay. And then for 26, 696,832.
Yeah, to the nearest whole number again, so 697.
697.
Then-
And number 26 is the same thing.
What do you mean? It's the same thing.
Wait. Number 25 was 697.
No, sorry. I might have messed it up. No, the number 25 is 388.
Oh, okay. I messed that up. Yeah. And then number 26 is 397.
Is 697.
Okay.
Did you say?
Yeah.
You're not connected anymore. Like
I'm
at
not?
all. No. Sorry, I'm talking to Daniel.
Oh.
Huh? Yes, we're still here. I don't know if it's still recording. It says on here. Well, it's not my fault if the church in Ely doesn't have a good internet connection. Well, I hope it's still recording because you set that up. So yeah, on top. Well, is that saying like still that it's still recording on your screen?
Yeah, it says in Gireta.
Yeah, so it says that on mine too. So you're probably still going. So just click on the link and jump in the thing that you created. Yeah, it's just like 5 more questions. We can just go through that. Find the first quartile of the distribution. I'll start to work on that. First quartile. So
Okay. Oh man. So it still says that it's live, so yeah, should be fine. I'm sorry guys. I don't know what happened.
now it's all your fault, and
Well, I'm here in church, so I don't have anything to do with it. So we were doing the 90th percentile, right?
yeah, we did it, and it's
696.832.
yeah. By the way, you gotta round to the nearest whole number, so 697, and even the previous one.
Oh, so the previous one was 388,
Yes.
and this one is 697. Okay. I missed that. Oops. Okay, so are you at 27 or did you go further down?
27.
So find the first
Still
quartile
rocking.
of the distribution of GMAT scores.
So 0.25 maybe.
So yeah, we have to find that 0.25, 0.25. It's a z-score of minus 0.674.
Mhm.
Yep.
So we multiply that by, what was it again? 120. And we add. So it is like 461.
Yes.
So you take the negative 0.6064
Point negative 674. Yeah.
4 times 120.54
Yeah.
plus 542.3.
Yeah. The mean. Yeah.
623.54. Or maybe it's gonna ask you to round. I don't know.
Whole number.
So 6.24. Or it's just 624. Yeah.
I came up with 461.
Me too.
Whoops. Huh. What did I do? So the negative, right?
Mm-hmm. Yeah, you
Yeah,
take
so you get the negative number and you add the 550, 42, whatever the mean.
Oh. Oh, so.
Does it make sense?
For 61? Yeah.
461, yes.
Okay. Yeah, I gotcha.
Then question 28 has to find the third quartile, which has the same z-score. So we get the same z-score, 0.674. So we take the positive now. 0.674 times the 120. What's that? 120.
0.54.
0.54 plus 542.3, and we get 624.
Mm-hmm.
Consider a simple random sample of 15 students taking the GMAT. What is the mean of the distribution of sample means scores for all such samples?
Shouldn't be the same.
Yep.
So 542.3. Right? You guys agree?
Mm-hmm. Yeah.
What is the standard deviation of the distribution of sample mean scores for all such samples?
Just a regular standard deviation?
No, because it's divided by the square root of 15 in this case.
Yeah.
So standard deviation is 120.34. No.
125.4, I think. Yeah, 54. 120.54 divided by the square root of 15.
0.54 divided by square root of 15 is 31.
Point?
Yeah, 1 second. Going to the right side of the second question. Okay, question 30. 31.3.123.
Mm-hmm.
1, 2, 3 is the decimal places.
Yeah.
Fun.
Yeah, it would have been cool if it was like 321.123.
Okay, question 31. What is the probability that the sample mean GMAT score for an SRS of number 15 students would be greater than 600?
Okay.
So
Let's find the z-score.
600 minus, no, yes,
Okay.
500, I can't remember, it was not 542.
You have it in question 29. Just look at the answers of 29 and 30.
Is 442.3, right?
542.3, yeah.
Okay, equal. Divided by the standard deviation, 120.54, divided by the square root of 15. 1.854.
1 point?
854.
I did something wrong.
You do, you did. Or I did something wrong. Either or.
No, you're right.
So now,
So is it, what did you come up with?
the area is 0.9.
No.
Oh, wait, what?
Sorry.
So I didn't get how to do this one actually.
Okay, so we want to know what is the probability that the score is
Yeah.
greater than 600. So we get we find the z-score for 600.
Mhm.
And so the z-score for 600 is like 600 minus the mean, 542.
Mhm.
And then we divide everything by the standard deviation divided by the square root of 15, because it's the sample.
Okay.
Yeah, we need to use the standard deviation for that sample mean, you know.
Okay.
So we know that that will be the population's standard deviation divided by the square root of the sample size.
Okay.
Then we use we put the z-score in the applet, and the area, which should be the
Oh, I
probability
see.
that comes to me, is 0.032.
0.032. Yeah.
Perché la formica save.
I'm going to submit it and see what happens. Oh, there's one wrong. There is one wrong.
Which one is it?
Number
I guess you did it right, Daniel.
number 13.
Wait, so for 31, was it 8.61 or no?
For number
Oh,
The last one, 31?
0.031.
no 032.
Oh, yeah, sorry.
0.032.
0.032.
0.032.
So number whatever. Number
13 you said, right?
13, yeah. It's not the variance.
Huh. What quantity is equal to the sum of the numbers in the squared deviation column? Oh, in the squared deviation column. Isn't the standard deviation?
No.
No, that makes no sense. Maybe none of
is
the. Well, it can't be the mean.
No.
Doesn't make any sense.
We put variance, didn't we? For that one?
Yeah.
That was wrong?
Yeah.
Should I try?
Am I
Wait.
Am I
No,
allowed?
wait, I'm checking.
Am I allowed to go and check in the textbook?
I think so.
Is that the second one? We're not in live. Anything interesting? Well, in the column is the variance.
So it's not the mean, right? It's not the variance.
Well, I thought it was the variance. Sounds.
So, Daniel,
Yep.
excuse me, Gabriel,
Yes.
you haven't submitted yours yet, right?
No. Did you?
No, but should I just submit it with standard deviation?
As you wish. Okay. I was honestly looking at the
A textbook?
at the textbook, and I thought I was understanding the textbook, but now I'm not sure. It has 3 columns. There's the column. Is it a lesson 4? Daniel, are you looking at that too or not? Daniel.
Hello. Okay.
Hey, hello.
I can hear
Hello.
you. Hi.
Daniel.
I can hear you. Can you hear me?
Yes.
Okay. I don't know what's happening here today.
Are you looking at the textbook by any chance?
I'm trying, yeah.
Try. Okay.
I remember a table.
Yeah, lesson 4.
Was it lesson 4?
Yes.
Yeah.
Okay.
And there is a table that has like the square x minus b. But then it's also timed by p. Right?
Yeah, but there was something else that it was talking about the fact that you use the standard deviation for certain things, and then you use that value for some other things.
Okay, I think I'm just gonna try and see what happens.
Which one are you gonna try?
It's a good question. I won't say the mean because it makes.
Okay, I'll try standard deviation and I'll submit it right now.
No, but like, wait a second, because like you also have none of these is correct.
Yeah, and that's what I'm thinking.
What quantity is equal to the sum of the numbers in the squared deviations column? You know, because if you sum up all those
square deviations, isn't that you get to the mean?
But you'd have to divide, right, by that number.
If you sum all numbers in the square. But all, yeah, even I don't know. I'm not sure if they mean like all the numbers or all the results from the square deviation.
Yeah, all the results. You know, if you get all the results.
Hey guys, number 13 is none of these is correct.
Yeah, that's what I'm thinking.
Oh, did you?
I submitted it. Yeah, I submitted
it. Good way to do it.
All right.
We are a little stubborn, as you notice.
Yeah, I'll have to go and check what that really is, though. All right, so I think we can probably just end it here. The live thing. I'm going to